A charge Q is placed at the center of the line joining two equal charges, that is another Q. The system of the three charges will be in equilibrium if Q is equal to, okay, one charge is there, it is so placed at the center of the line joining, okay, that is denoted with a small q, and joining two equal charges, it is denoted by this capital Q. The system of these three charges will be in equilibrium. They are going to say it is in equilibrium. If Q is equal to, then in what condition? Okay. So we know some conditions here. There is some of the informations, that is for equilibrium of charge Q, the force applied by the charge, that is another whatever the Q is there, and one more Q and Q should be in equal in magnitude and opposite in direction. The direction must be in opposite direction. Then this is only possible when another, that is a Q, has negative charge. Opposite means another Q it is in has the negative charge. Then if D is the distance between both pairs of Q and Q, then we can use Coulomb's law here. What is the Coulomb's law here? That is force QQ, we can write F QQ is equal to minus direction of F QQ. Okay, then we know the formula of this one, that is 1 upon 4 pi epsilon naught into, that is a Q times Q divided by D square, which is equal to 1 upon 4 pi epsilon naught times Q square divided by 2 times D whole square. Whatever the common terms is, they just get cancelled. There is 1 upon 4 pi epsilon naught, 1 upon 4 pi epsilon naught will get cancelled. And here it is 2D square is there, and here 1 Q get cancelled, and here this square will get cancelled, the Q is remain as it is, and the D square and the D square is get cancelled. Then this D square will cancel, then the 2 square becomes 4 here. Then this is also get cancelled. Then I can write Q is equal to minus another term is negative direction, minus of 1 Q, it is remains as it is, that is Q divided by 4. So this Q must be equal to minus Q upon 4. Option A is our right answer.